In this video, we're going to be solving rational equations. Notice the difference. In the past, we were adding or subtracting, multiplying or dividing rational expressions. However, here, we're going to be solving equations. So the steps to do that, and I'm going to show you in subsequent problems, is to eliminate fractions by multiplying the LCD. And I'll show you what I mean by that. Now, the important thing is, anytime you have rational equations, when you have variables in the denominators, you always have to ask yourself, whatever solution you get for x, is it a valid solution or is it extraneous? Is it mathematically correct, yet in that problem it's not a possible solution? And I'll show you what I mean. But this is going to involve not only solving, but checking. So when we get here to our first problem, you're going to notice that this problem looks a little different than what we were doing before. Before, we were simply adding, but we were missing this equation part of it here. We were just getting like x over 3 plus 3x over 4. Now we actually have an equation. We know what it equals, and now we can solve for our variables. So our strategy here is going to be to multiply everything by the least common denominator. So we look at our denominators. We have 3 and 4. We know the least common multiple of those would be 12. And so we're going to multiply every single term by 12. So when I multiply x over 3 by 12, the 3 is going to cancel. I'm going to be left with a 4, and I'm going to multiply that by x. When I multiply 3x over 4 by 12, the 4 is going to cancel. I'm going to be left with a 3, and I'm going to multiply that to the 3x. And over here, I have no denominator, so I'm just going to get 2 times 12. And so now notice that this problem became much simpler because I was able to eliminate the denominator. Now I just get 13x equals 24. I'm going to divide both sides by 13. And I'm going to get that x equals 24 over 13. And that is a valid answer. And I don't have to check it here because notice my denominators are numbers, okay? I have to start checking when I see denominators that are variables. So I'm going to go to number 2, and again, I'm going to look at this problem. I see that it's a rational equation, so I can multiply by the LCM or LCD. In this case, 5 and 3 have a common multiple, or a least common multiple, of 15. So when I multiply the first term by 15, the 5 is going to cancel. I'm going to be left with 3, and I'm going to multiply it by 2x. When I multiply 5x by 15, I'll figure that out after. And when I multiply the 4/3 by 15, the 3 cancels, leaving me with a 5. So it's going to be 4 times 5. And so when I do the math, I get 6x plus 75x equals 20. So I'm going to get 81x equals 20. I'm going to divide by 81, and I'm going to get that x equals 20 over 81. I'm going to keep going now to number 3. And again, number 3, notice there's 3 denominators, and I've got to find the LCM of all 3. Luckily, 10 is the LCM. I didn't have to search too hard. The first term, when I multiply it by 10, the 5 is going to cancel. I'm going to be left with 2 times x. When I go to the second term, the 2 is going to cancel. I'm going to be left with a 5, so I'm going to get minus 5 times x. When I go to the 3, it's just going to be 3 times 10. And when I go to the last term, the 10s are going to cancel, leaving me just with a 3x. So on the left, I'm going to get a minus 3x. On the right, I'm going to get 30 plus 3x. Do not stop here and think that the 3's cancel out. Please follow through and do the math correctly. Subtract 3x from both sides. You're going to see that you're going to get minus 6x equals 30, and then you're going to divide by minus 6, and you're going to get x equals minus 5. Okay, now we go to the last one, and now we're going to start the process because we see that variable in the denominator where we are going to have to check our final answer. So I notice I only have 2 denominators. Both of them are x, and so x is our least common multiple or least common denominator. When I multiply by x, it's going to cancel, leaving me just the 15. When I multiply the 4 by x, I'm going to get 4x. When I do 6 over x times x, the x at the bottom is going to cancel, so is the one at the top, so it's going to be just 6. And then I'm going to do 3 times x. And then I've got the plus 3 and then 3 times x. Okay, so I've got my problem set up. Now I'm just going to clean up each side. I see that they're fully simplified. So now I'll just subtract 6 from both sides. And that'll give me 9 minus 4x equals 3x. I'll add 4x to both sides here. And I get 9 equals 7x. And I'll divide both sides by 7. And I'll get x equals 9 over 7. And this is where I need to check my answer. Because again, notice that my denominator is x in a couple places. So I need to ask myself, what can x not be, right? Or maybe not so much x, but what can the denominator not be? Remember, I can never have a denominator of 0. So x cannot equal 0. So in this case, since x equals 9/7, I'm fine. Okay, a lot of times I'll look at the denominator itself first, and I already know before starting this problem that x can't be 0. And so if I end up with an x equals 0, I know that answer is extraneous or invalid, and there would be no solution. But in this case, thankfully, it's fine. So we keep going here to the next page, and again here we ask ourselves, what is the GCF of the denominators? Now, the GCF of the denominators here would have to be the expression 5x plus 6 and 2. It'd have to be both of them. However, this particular problem is one exception kind of to the others, where notice all the others have multiple terms on each side. It's got like 2 terms on the left and 1 term on the right. Here's 2 terms on the left, 1 term on the right. But this one has 1 term on the left and 1 term on the right. So this is really almost, you could treat it as a proportion. And you could save yourself a little time with this one. Remember that with proportions, you can multiply across. You can say 2 times 10x plus 3 equals 1 times 5x plus 6. And by doing that, you already eliminate the denominator. You turn it into a very straightforward problem, which is now super easy to solve. So you're going to distribute the 2. So you're going to get 20x plus 6. Over here, you distribute the 1. You're just going to get 5x plus 6. You'll subtract the 5x from both sides. You'll get 15x plus 6 equals 6. Subtract 6. You're going to get 15x equals 0. This is still valid. This is still allowed. You know, sometimes when we see something equals 0, we sort of freak out. But we get here that x equals 0. And so 0 is a very plausible, very acceptable solution. Now, again, you might see x is 0 and say, oh, it can't be 0. No, x can be 0. You have to look at the denominator and see what does that x equal 0 do to the denominator. Well, 5x plus 6, if I substitute in 0 for x, I'm going to get 0 plus 6 or 6. So my denominator here, if x is 0, is 6, and that is completely acceptable. Okay, so this is valid. No worries here. When I go to the next problem, I get here, I see that my denominators are x and x minus 5. And so what I'm really going to be doing is multiplying everything by x and x minus 5. So when I go to the first term, 1 over x, and I do that, the x's will cancel, and it'll leave me with 1 times x minus 5. When I do it to the second one, the x minus 5 will cancel, and it'll leave me with 2 times x. And when I go to the third one, I'm going to do 0 times x minus 5. However, we know that that's going to end up equaling 0. Anything times 0 is 0. So over here, I'm going to get x minus 5 plus 2x. I'm going to get 3x minus 5 equals 0. I'm going to add 5 to both sides, so I'm going to get 3x is 5. And then I'm going to get x equals 5 over 3. And so again, I've got to go and say, well, what if x is 5 over 3 here, is that valid? Yes, it doesn't make my denominator 0. If x is 5 over 3 here, my denominator is still not equal to 0. And so this is completely valid. In fact, just out of curiosity, what 2 values can x not equal? X cannot equal 0, and x can actually not equal 5. These would be the 2 values that if my final answer were one of those, that's what would be extraneous and lead to no solution there. Continue doing the same thing over here in problem 7. So again, I'm going to multiply, oops, wrong color. I'm going to multiply here by the least common denominator, which in this case is going to be 2x plus 1 times 2x minus 1. And so again, when I multiply that first fraction by it, the 2x plus 1s will cancel out, and it'll leave me with 7 times 2x minus 1. When I do the same thing to the second fraction, the 2x minus 1 will cancel, so it'll leave me with minus 8x times 2x plus 1. And then when I do this last one, it's going to leave me with minus 4 times this entire thing. Now, I notice that that's a difference of squares, and for just to kind of expedite it here, I'm going to actually square that so that it fits there, right? Now I'm going to do my distribution and start to simplify this a little bit. So 14x minus 7, this is going to be minus 16x squared minus 8x equals minus 16x squared plus 4. And so the nice thing here is I have a minus 16x squared on both sides, so those will cancel, which is a good thing. Solving with the x squared is a little bit more difficult. Again, we have 14x minus 8x. That leaves me with 6x minus 7 on the left, and it leaves me with a 4 on the right. I'm going to add 7 to both sides, and I'm going to get 6x equals 11, and I'm going to divide both sides by 6. So x equals 11 over 6. Once again, I have to double check and make sure that this is not a problem solution. Is it extraneous for us? And I recognize that it's not. If I plug 11 over 6 in here or here, my denominator is not going to end up being 0. And so this is completely a valid solution. And lastly, on this page, notice that this denominator over here is really a difference of squares. It's x minus 2 times x plus 2. And so when I go to multiply by my least common denominator, I know that it's just x minus 2 times x plus 2. And again, I have to multiply everything by that. So I take the x minus 2 out, and it leaves me with 1 times x plus 2 equals, I take the x plus 2 out, and it leaves me with 3 times x minus 2. I have the minus 6x, right? And then notice that if I multiply, both of them are going to be gone, and I'm just going to be left with that minus 6x. So I'll distribute these numbers. I get x plus 2 equals 3x minus 6 minus 6x. I'll clean up the right side. It's going to be minus 3x minus 6. I'll add 3x to both sides. And I'm going to get over here 4x plus 2 equals minus 6. And then here I keep going, right? I'm going to get 4x equals, I'm going to subtract 2 from both sides. So I'm going to get minus 8. And I'm going to divide by 4. And I'm going to get x equals negative 2. And so now I have an answer of x equals negative 2. Now I have to go back and again check. And I already see that there's a problem. Not a problem here. If x is negative 2 here, my denominator is negative 4. That's okay. However, negative 2 here gives me a denominator of 0. And therefore, this is a no solution. Okay? Because the solution that we got is extraneous. And that means it's mathematically correct, but invalid in this problem. Again, we have 4 more problems. We're just going to continue to do the same thing we've done and just get more and more practice at the same. So again, I look here, my least common denominator is going to be x minus 4. So when I multiply by it, I'm just left with the 3x. When I multiply the 5 by it, it's going to be 5 times x minus 4. And when I multiply the last fraction, it's going to cancel it out. And it's just going to leave me with the 12. So I just distribute 5x minus 20 plus 12. Again, I'm just going to keep doing the math here. 5x minus 8. I'm going to subtract 5x from both sides. And I'm going to get minus 2x equals minus 8. And divide both sides by minus 2. X equals 4. And again, I have to ask myself, can x equal 4? And when I go back to the problem, if x is 4, my denominator is 0. And so yet again, this is a no solution. Okay, because x equals 4 is extraneous. And once again, extraneous means that while mathematically it works out, in the actual problem that it's in, it's an invalid solution because it would make your denominator undefined. So we keep going. I go to this last, or number 10 here, and I see that my least common denominator is x minus 1 times x plus 3. And so again, I'm going to multiply this first term by it. Both are going to cancel, so 12 is just going to be left alone. When I go to the 3 over x minus 1, I know that x minus 1 is going to cancel, which is going to leave me with 3 times x plus 3. And when I go to the x minus, or the 2 over x plus 3, the x plus 3 cancels, leaving me with 2 times x minus 1. So all my denominators are gone. Now this is a much simpler problem. Distribute the 3. So 3x plus 9, distribute the 2, 2x minus 2. Simplify the right side here. I'm going to get 5x plus 7. I'm going to subtract 7 from both sides. I'm going to get 5x equals 5. And so then we're going to divide both sides by 5. And we're going to get that x equals 1. And again, we do have to go back in here and ask ourselves, is this something that is valid? And so when I say, well, can x equal 1, I go through all of my denominators, and I do mean all of them. I have to go through every single denominator in this original problem, and I realize that x cannot equal 1 here, and it can't equal 1 here, because it would make both of those fractions have a denominator of 0, which makes them undefined. And so again, there's no solution here, because x cannot equal 1. So we go over here to number 11, and again, I'm going to start by factoring this trinomial, right? This is going to be an x plus 3 times an x minus 2. And so again, I'm going to multiply every term here by this LCD of x plus 3 and x minus 2. So this one has a denominator of x minus 2, so that's going to leave me with 1 times x plus 3. This one has a denominator of x plus 3, so that's going to leave me with 3 times x minus 2. And this one, both of these will cancel out, so it'll leave me with just the 4. So at this point, I just have to distribute the 1 here. I have to distribute the 3 here. And then I have to, simplify my sides. So I get 4x minus 3 equals 4. Add 3 to both sides. So 4x equals 7, and then divide by 4. So I get x equals 7 over 4. And so again, I have to ask myself, can x equal 7 over 4? And notice that, yes, it can. This is a proper solution. The only things in this problem that x cannot equal 2, x cannot equal -3. And so since this is neither 2 nor -3, it's a valid solution. Last problem, we go through here and we ask ourselves again, what is my LCD, right? However, notice that this last one can be factored. So I'm going to factor out an x. It's going to leave me with x plus 3. And so I recognize that the least common denominator here is going to be x times x plus 3. That includes every factor there, or every denominator factor. So now I'm going to go and I'm going to multiply everything by that. So when I multiply 6 over x by x times x plus 3, I know the x's will cancel, and it'll leave me with 6 times x plus 3. Then I have minus 2. When I do this one, the x plus 3 cancels, leaving me with minus 2 times x. And then the last one has both the x and the x plus 3, so it just leaves me with the numerator of 3 times x plus 5. So now I'm going to distribute 6x plus 18 minus 2x equals 3x plus 15. I'm going to simplify my side. I get 4x plus 18 equals 3x plus 15. Subtract 3x from both sides, and I get x plus 18 equals 15. Subtract 18 from both sides, and I get x equals -3. And so that's my solution there. However, again, anytime I see a variable in the denominator, it makes me think, is this solution valid or is it extraneous? And notice that if x is -3, this denominator here or this one is also going to be, right? Either one of these is going to end up being a 0. And so this is, again, extraneous. And so this is a no solution problem again.